In this series of videos I'm attempting to repair and restore a DEC PDP11-34A. In the videos so far in this series I've been through, tested and repaired the console and its controller card. I've, as you can see, stripped the machine down, so I have just the CPU backplane, the power supply, and I can use this now as a test bed for testing the various cards, and we can put all the cards, or at least all the important cards, back in this and test the system standing out on a bench like this. It makes it far easier than trying to test it in the big heavy case. So we have the console working. Did appear there was a faulty 7-segment display in the console display and keyboard unit. That turned out to be just some broken pins on the socket that the display was plugged into. In fact, when I moved the displays around, I unplugged that one and swapped it with another one, I got a different segment not working in a different display, and it was just the pins had corroded inside the sockets and they were taking it in turns to snap off. So I replaced all 6 sockets, plugged the displays back in, and it seems to have resolved the problem. It could in theory be a broken connection inside one of the displays, but it does look like replacing the sockets has completely cured that fault. So the console does now appear to be fully functional, so we can now use this, as I say, to test the other cards, and the one we're going to look at in this video is a serial card. So this is a single channel serial card. It does handle RS-232 as well as current loop, and it also contains a real-time clock module to allow the generation of regular interrupts. So if you want a regular event to occur, then you can use this card to trigger an interrupt. So what I'm going to do is power off the test jig, plug this card in, I'll get it connected up. We're just going to use 3 connections for this test: ground, transmit and receive. I've got the card configured to 300 baud, 8 data bits, 1 stop bit, no parity. And as I get this plugged in, I'll bring the terminal up into the corner of the screen, and we'll see if we can get this to work. So I've got a terminal program running on a PC, and I'll get this connected to it and see if we can use our test jig and see if this card actually works. I don't know if this works yet. I've just been through and checked all the switch settings. I've done the usual static checks with the test meter, looking for shorts. I've gone through and checked every single pin to make sure it's not shorted to ground, apart from the ones that are ground, of course. And it seems to be fine, so the next thing is we'll power this up. I still don't have the fans fitted to the power supply, but this combination of cards, it's only going to draw about 4 amps, so it should be fine. I still only have 1 termination card in the back plane, so I can send data to this, but I won't be able to read data out of it because we'll get a bus error, but I can still test this to send data to the terminal. So I'll get this set up and we'll see what happens. As you can see, I've got the serial card plugged into the backplane, and one of the nice things about this setup is I can put the card I want to work on at the front. You're normally restricted in the PDP machines as to the order you put the cards in. You can use risers, but it's a bit inconvenient. This is much easier, and it's a nice comfortable way of working it on the bench. So as I said, I did static testing to make sure there were no shorts on this. I've got it plugged in. I've only got 1 termination card, as I said, so I won't be able to send data in both directions until I do that, but I do have a spare card, but it just gets in the way for the video. But if you want to fully test the cards, you need a terminator at both ends. Without the CPU here, the bus signals are not properly handled, and it will cause a bus error, and that will terminate the cycle. So you do need a termination card at both ends. If you have another one of these cards at the front, it will properly handle the signals and it will prevent the bus errors from terminating the cycles. So what I have set up, as I say, I've got the card plugged in. I've got this connected to my PC through an RS-232 cable. The only wires I have connected are ground, and then the receive and transmit lines are connected to the appropriate lines on the serial cable. The scope is monitoring the RX and TX lines, so we'll try and power this on and see what happens. Hopefully the magic smoke will not escape. And the first important step, of course, is that the console comes back up. If it doesn't, we'll immediately turn off and see what's gone wrong, but we'll try and power this up. And I've put the front panel on, as you can see, so you can see the switches, and also it should make the display easier to see. It's got better contrast with the cover on. Apologies for any flicker on the display. That's, as usual, the interaction between the refresh rate of the display and my camera. So we'll turn this on. So good news is we've got the display come up, we've got the unhandled signal causing a bus error, so we can clear that. We'll now put the console software into its proper mode, so we go into diagnostics, exit that, and we get a bus error again, which we can clear. This bus error will go away, by the way, if you put a second termination card in. So what we can do now is start looking at the data. So I'll start by bringing the terminal up in the corner of the screen, and so you'll be able to see what appears on there, if anything. And it's just really, in theory, going to take the raw data that we output from the card, and hopefully the terminal will be able to see that. So that is pretty much all this card really does. So the first thing we have to do is enter the address for this card. Now I've got this configured. You can change the address, although it is fixed if you want to use this as a console. I've got two of these cards. One will be used as a current loop card, in which case I can change its address. This one is going to be used as a terminal, so I am restricted to what address I can use for this. And the addresses are 777560 for the receive status register, 777562 for the receive buffer, 777564 for the transmit status, and 777566 for the transmit buffer. And that's the buffer that we are interested in at the moment. So we want to set 777566 because that's the address we need to write the data we want to send to. So we'll enter that, so 777566, load address, and we now enter the data value we want to send. And you should see on the terminal and on the scope some activity. So I'm going to set a value for an uppercase B, which is octal 102, so 000102, and we deposit that. So we see activity on the scope, and we also see that the character has been received by the terminal, which is very good. It means that the card is working at least in transmit mode. So we'll send one more character. So again, we do the same thing, 777566, load the address, enter the data value. This time we'll send an uppercase C, so that's 000103, deposit that. Again, we see the data on the scope, and the character has appeared in the terminal. So clearly this is working, at least in transmit. If we want to receive, we have to fit the second termination card, otherwise we will get a bus error when we try to read the receive register, because it's a two-way process. We're sending a request and then expecting a request back, and that doesn't work without the termination at the front. So as you can see, it's a very good way of testing these cards, very convenient, easy to get to it, and if we want to use a scope or a logic analyzer, we can easily attach that. We can access the complete bus and backplane, so if we want to, we can test all the signals. We can easily get to them without having to sort of fit riser cards and everything else that normally cause a main headache. So hopefully that's been of some interest to anyone that's trying to fault find cards on these machines. It is not particularly difficult to get the machine stripped down to this level. It's only a few screws that hold the backplanes in, and then it's just 6 screws that separate the power supply from the main chassis. So it's a 10-minute job to get the thing split. Again, I've taken the console and display out. As you can see, that makes life much easier as well to have it on the bench like this. And although it might take probably half an hour to get this set up off the machine and onto the bench, it's going to save you so much time and trouble, and especially if you have a difficult fault to track down, this is a very good way of doing it. The only restrictions are if you need the CPU running, they do have to be in the first two slots. These two front slots are not the same as the rest of the slots, and so your CPU does need to be in the first two. You can of course use a riser card, it makes it less convenient, but for cards like this where you don't need the CPU, and you don't need the CPU for the vast majority of cards that go into these machines, and so this is a very good way of working on them. Generally speaking, the only time you need to have the CPU card fitted is when you're working on the CPU card, so it's at the front anyway, so it's quite a nice way of working. So hopefully that was fairly clear. It's not much to show, I'm afraid, because it works, but I've got a second one of these. If that's got a fault, I'll post a separate video on the fault finding and repair, and also if this turns out not to receive data, I will of course post an update video on the repair for that. But it appears as if though it's likely to work. We'll just have to see how it goes as the testing progresses. So in the next video we'll fit the second of the termination cards and do some more testing, and start to reassemble this entire machine and see how far we get before we encounter the next fault.